Hello, my name is Alana Murphy, and I'll be presenting Team 2's Chapter 8 exercise, Predictive Modeling with Classification and Regression Trees. So exercise 8.1, the confusion matrix. So using the data in figure 8.10, build a confusion matrix as shown in Chapter 7 on logistic regression and calculate the precision, specificity, sensitivity, accuracy, and F1 score of the decision tree. So here you can see we have our basic confusion matrix up here. Just as we did in class, this kind of is the basics of like the decision tree. We use the Titanic data to start our analysis with this tool, as seen up here. But here we have our precision. So we have the frequency, numbers, and then our percentage. So for precision, specificity, sensitivity, accuracy, and F1, we have all of our, we have all of our percentages calculated there. For exercise 8.2, decision tree modeling of employee attrition data. So using the dataset employee attrition, see Appendix A for details, we're to create a decision tree to predict attrition. So this is the data we've been working with a lot for these exercises. And so we went into Satisfy and pulled up that data set and created the decision tree from there. So the first thing we were asked, what predictive model does Satisfy propose? What interpretation do you make of the model with regard to the predictors? 3, analyze the confusion matrix and comment on the performance of the model. Examples include comment on the accuracy, false negatives, potential false positives. And 4, how well does the decision model perform compared to the logistic regression model you created in Chapter 7? So here you can see our tree that we created, and so they just branch off by each variable. So monthly income branches off, job role branches off. And here we can see the variable's importance. So based on the analysis, we can see that monthly income kind of sways our model more than number of companies worked at. And here we have our confusion matrix, just a yes, no, pretty straightforward variables there. And our F1 score up here of 0.51, observations used 1,470. And down here we have the attrition model. So the predictive model variables used, we used monthly income, overtime, job role, age, total working years, distance from home, number of companies worked, hourly rate, environment satisfaction, education field, and daily rate. And here's just a bigger image of that confusion matrix that we created with the employee attrition dataset. So in regards to some outliers that may have been raised, false positives were seen in 2.11% of cases attrition was not observed, and false negatives were seen in 62.03% of cases attrition was observed. So we've got that false positive rate to a very low and manageable level, but that false negative rate is a bit too high. So that's definitely something we'd want to iron out if we were to continue working with this data set and this model. But in regards to accuracy, the model is 88.2% accurate. And here you can see just another breakdown of those numbers. Nope, I just went backwards. And then sorry, I'm having some technical difficulties today. So then using these numbers, we can see that false positives were seen in 2.6% of cases, attrition was not observed. False negatives were seen in 51.48% of cases, attrition was observed. So again, the false positive number looking good, but false negatives still a bit too high. And accuracy, even that has risen to 89.5% for this model. So that is promising. And yeah, that is all. Thank you.